Next presenter is Adina Moraru, and her presentation is the role of soft data to understand flood dynamics in an ephemeral mountain rivers. So, Adina, please.
Thank you for introducing me. I'm going to focus specifically on the 2017 flash flood in Western Norway. The village by this river was isolated and devastated after the flood, so the restoration work quickly removed or erased most of the traces available from the event. The visual observations and documentation obtained during the flood was therefore crucial to expand our understanding dynamics during this event. The methods shown in figure 1 on the left of the poster, starting from the top, a hydrologic study carried out by Bruland in 2020 provided a hydrograph and important field data. Combining photographs, videos, calls covered by the media of the flood event and witness testimonies, it was possible to estimate the flooded area at the peak discharge. Please look at the subfigure 1A. The soft data combined with the differences of the elevation models and the orthophotographs before and after the flood helped identify the critical location, see subfigure 1B, and the preferential flow paths, see subfigure 1C. The maximum wetted and dry areas throughout the whole flood event were the support of all the before mentioned data as shown in subfigure 1D. Figure 2 in the center of the poster results and shows maximum wetted areas in blue. The critical locations numbered CL1 from upstream to downstream and indicated by white circles and the preferential flow paths marked by purple lines. Two of the critical locations, namely CL2 and CL3, were located near bridges, and the other two critical locations were near a bank with very fine material that was easily erodible. The preferential flow paths showed that the erosion occurred mainly in the left floodplain. Remote sensing techniques alone provided good information on processes, as well as the migration of the original channel to the left floodplain. The soft data helped expand the preferential flows to a wider area, as well as understand the sequence of events that occurred that day, which was very valuable to flow paths. The visual documentation provided validation on critical locations, especially upstream of the bridges and by the channel downstream. The main uncertainty in this study was due to three main factors. First, the partial documentation due to inaccessibility at the peak of the flood, especially in the right floodplain. Second, inadequate data resolution. And third, expertise and subjectivity of the user, although it's expected that the accuracy is quite high in the urban area, especially due to high density of redshift. In summary, soft data can be used, it's very valuable to refine the hydromorphological information by remote sensing, especially such as critical locations, flow paths, and maximum inundation area, especially when post-flood validation data is not available. The dataset presented in this study can be used to calibrate and validate models of this flood, as well as to improve the accuracy of flood early warning systems. You may find more information on this and other studies by scanning the QR codes in this poster. Thank you for your attention.
Thank you, Adina, for your presentations. I have just one question. You mentioning here soft data and some aerial data. You have collected this data by aerial survey?
By what?
Aerial survey.
The soft data specifically was not always collected by aerial survey. We're actually talking about level data where the witnesses took photographs and recorded videos and then were interviewed afterwards. So it was more at what one could see as walking through the streets during the flood.
We have a question in the Q&A box for Adina by Thais Yamazaki. And he or she says, a very interesting presentation. Which types of soft data were used in the study? How were they obtained?
Thank you for the question.
I think you already, you partially
yeah,
already answered this question, but
it's true. So what I called soft data in the study is everything that would not be remote sensing, so not aerial imagery or DMs, but rather things that are actually very hard to georeference, such as photographs or videos, but also media coverage of the flood event, stories told by the witnesses, and many of them were obtained live during the event because my project leader had to leave in this village and he actually witnessed the flood. So he was fast enough to record everything and take as much data as possible. It was great. Really, it doesn't happen often that you're there to witness a flood. But it just, I think the peak of the hydrograph happened very early in the morning. So people were awake and could witness it. And they were so shocked that they just took photos from different spots of the village. So it's not that my could actually run around the whole village to take as many, as much documentation as possible. So it helped that there were so many people involved. I guess this is the point of citizen science to a certain extent. And then there were also video footages by helicopter from the national TV channel because, well, everyone was very shocked. The main road was the original road and got destroyed. So all the inhabitants had to be rescued by boat. And so, yeah, there was very good footage available. So one could see the whole flow zone from there as well. So that was very, very handy. And it really helped to actually know the times at which each of the footages were taken and know at what time each of the houses was flooded or affected, because people were very mad and saying, you know, like, yeah, all my stuff was dragged by the water at this time or not. And so we had some of the we had possibilities to create a time sequence of the event. It was very helpful in my opinion.
Thank you.
I hope it answers the question.
Yeah, I think it does. And well, I also have a question for you. I was wondering if you have tried to perform a numerical simulation of this event and use your soft data to validate or calibrate the model, or if you're planning to do so in the future.
I would say that this is definitely the outlook of this preliminary study. The first step was obviously to see if we had calibration or validation data or considering modeling the flood. And I do believe that this could be used to calibrate the model. And I have personally run a model with Eber, developed by UPC, I have validated it as well. It's just, it was too much to provide in this one study. So it's something that it's soon to be submitted. So I hope you see it soon, actually. But yes, the issue is that it's a very complex event because it had a heavy amount of sediment transported and wood planks and so there's a lot of morphodynamics involved. It's not only the hydrodynamics. So far I have focused on the hydrodynamics, but I believe that there's a lot that could be done on morphodynamics. But yeah, I hope you can see that soon.
Thank you.
Adina, I have one question.
Yes.
Because there are many studies nowadays, they are using artificial intelligence technique to collect data from social media, some data from videos or some people charts. So you have used such a data in your study or planning to use the data in future?
So we definitely have a lot of data. but we did not use artificial intelligence to gather or retrieve the data. I assume that that's the aim of or that would be the role of the artificial intelligence in this case, right? To reach as much information available there as possible. We have not done that. I would like to use the artificial intelligence perhaps to improve the model in a way. So use it rather as a modeling technique rather than as a data retrieval technique. But I put so much work to putting together all the validation data that I realized that in fact that's not sustainable and would be so much more optimal if an AI model would do that for me. So I do believe that for future cases, especially for much larger areas, because this was about an 800 meters long reach, is very, very manageable. But for a much larger study area, it would not be operational to have a researcher carrying out and compiling all that data. So I do believe that there's potential for AI in this case.
Okay, thank you.